Okay, today's lesson for Monday, the 6th of February, was about continuing Friday's lesson, and it's about using these angle and arc theorems to solve for missing arc measures or missing angle measures. So we started on page 17 in our packet, and if you look at this one, at the top of each page is going to be the picture, and then we're going to fill in the theorem, and then we're going to write the formula. So this one in particular has a vertex, angles with a vertex at the center, and in this case it says the arc measure is equal to the central angle measure. So this is a central angle, the angle's vertex is at the center, and so it says the measure of the angle is equal to the measure of the arc. So looking down below, you can see it starts off fairly easy. We have a question mark here, so we're solving for the measure of the arc going from this point here to this point here, and we know from our formula it's equal to the measure of the central angle, and so that arc measure is 145 because the central angle measures 145. Moving on along to number 4, this one gets a little bit more complicated as we go, and so I wanted to find the angle measure of this angle right here. Or not this angle, but this arc, which is going to actually equal to the same as that angle measure. So looking at this, I know that this angle measure is 46. That means it's a central angle, so that arc measure, Vx, is 46. I know that this is a diameter, it goes through the center, so the semicircle here formed, its measure is 180 degrees, and I subtract 46 degrees, and we find that the measure of that arc is 134 degrees. Extending a little further, the measure of this arc, Vx, would be 180 degrees because it is a semicircle. Number 5 is a little bit more complicated. First thing I need to know is the fact that when I add up all 3 of these together, it has to equal 360 degrees. So I have 94 plus 136 plus 11 minus 17x is 360. Okay, so I just use my algebra skills. I combine like terms. 94 plus 136 plus 11 is 241. Minus 17x is equal to 360. Subtract 241 from both sides. Divide by negative 17. And I come up with x is equal to negative 7. So to find the degree of this arc, I would plug in negative 7 into the formula. And so it would end up being 11 plus 119 because I end up having a negative times a negative, so that's a positive. And so my degree of my arc there is 130 degrees. So I could be asked, what is solve for x? Or I could be asked to solve for the arc measure. Moving on along to page 18, we have the situation where the vertex is on the circle, so I have the angle measure is half of the intercepted arc. So the angle measure is half, so the measure of the angle is equal to 1/2 the measure of the arc. And we could go the other way and say the measure of the arc is equal to twice the measure of the angle. So, it starts easy and gets a little bit more difficult. So here, I know that the intercepted arc measure is 176. So I just take 176 degrees and divide it by 2, and it's 88 degrees. Number 7, it's going to get a little bit more complicated. So we actually want to solve for EC. That's where my question mark is. So I know what DC is, it's 97, and I can solve for DE by saying 92, the inscribed angle measure times 2, the intercepted arc is 184 degrees. So I take 184 plus 97 plus the question mark is equal to 360, combine like terms, subtract 281 from both sides, and that missing arc measure is 79 degrees. Number 8, Of course, it gets a little bit more complicated. Again, we have the vertex on the circle. So I know that the measure is so that 80 equal to 50 x minus. So I for an x due for the measure is 60. Or one of the last ones. Okay, I think the video caught up. So this is when the vertex is inside the circle, but it's not at the center. And the rule here is the angle measure, so the measure of the angle, is equal to the sum, half the sum of the intercepted arcs. So the sum of arcs divided by 2. And sum means to add them together. So in this situation, looking down, number 9, of course, is going to be the easiest of the two, is I know that one intercepted arc, or the intercepted arc of this angle that I'm solving for, is 75, and the intercepted arc of its vertical angle is 61, so 75 plus 61 divided by 2 is equal to 68 degrees. Now, it gets a little bit more complicated where I'm not solving for the angle, but I'm solving for a missing arc measure. In this case, I have an equation plus intercepted arc to add them to so mark divided by 2 because it's the sum equal to 8. So you can see you move and so by both sides becomes plus 206. And my arc or my measure arc is going to 20 degrees. Moving along 20. Page 20 is where the vertex is outside the circle. And so when the vertex of the angle is outside the circle, I know it's the measure of it's half the difference of the intercepted arcs. So I have, these are my two intercepted arcs, and I just have to subtract the measure of those two and divide by 2. And that's what my angle measure is. So looking, number 11 is quite simple. I have my intercepted arc measures, 175 minus 61 divided by 2, and so my angle U is 57 degrees. But then, of course, it gets a little bit more complicated with number 12. And so we have an arc measure that I don't know, and I'm going to say that's x minus 85 degrees divided by 2 is equal to 30 degrees. So I solve it by multiplying both sides of my equation by 2 to get rid of the divide by 2 on the left side. And then x minus 5. The last part of this is when two inscribed angles have the same intercepted arc. And we need to understand that if they have the same intercepted arc, like angle A and angle B, then they are both going to be congruent to each other, because angle A would be congruent to 40 divided by 2, which is 20, and angle B would be 40 divided by 2, which is 20 degrees. So you just kind of move forward and you see, okay, well, arc VW is 70 degrees, so I know that angle VAW and angle VBW are both equal to 35 degrees. Then moving down to the next one, number 1, I know that my angle BAC is equal to 40 degrees, so the intercepted arc, because it's an inscribed angle, is twice the angle, so that would be 80 degrees. And then moving backwards, I could say, knowing the intercepted arc is 80 degrees, then angle BDC is 40 degrees. And then the last one on page 22, I know that the intercepted arc here, AD, is 30. So I know that both of the inscribed angles that share that arc are half of that, which is 15. And that's the lesson for Monday.